So welcome again to this another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but we also do see and appreciate the beauty in the simpler problems. So today's problem comes from MIT 2022 Integration Bee Semifinal number 1, problem number 2, and we would like to bracket this problem in the polynomial fraction category. So it is the indefinite integral of 1 over into bracket x squared plus 1 close bracket cube. So again, as I said, this is an indefinite integral, and so it has no limits. So before I jump into the solution to this problem, I would like to shout out to our subscribers. Thank you so much. We are growing. We are growing at a very fantastic rate, and we do appreciate you for that wonderful support. For our first-time visitors, we would like to encourage you to subscribe to our channel. Here at Everyday Mathematics, we do like solving the harder problems. In this season, we are really focused on the calculus bit, specifically integration. But we like mathematics, so any topic that is of interest, we'll bring it to the fore. For our repeating visitors who haven't subscribed, we still do encourage you to subscribe to our channel, because that subscription will go a long way in improving our visibility. If you'd like to receive any notification each time we upload a video, please pause the video and press on the notification bell. So jumping on to the solution to this problem, the very interesting thing that you're always taught when you come of age as regards using trigonometrical functions to integrate is when you see x squared plus 1 in the denominator, a specific trigonometrical function would be of interest to you, and that is you would want to substitute tan theta in place of x. And so I would choose to use x be equal to tan theta. And that means that dx d theta is secant squared theta, or sec squared theta. And thus dx is also equal to sec squared theta d theta. Now, substituting in for x means that we have the integral of 1 over tan squared theta plus 1, all that cubed, times, in place of dx, we have sec squared theta d theta. So for those of us who know this identity, tan squared theta plus 1 equals to sec squared theta. So we can now put sec squared theta in place of tan squared theta plus 1. And so in the denominator, we have sec squared theta cubed times, now we have in place of dx, as we said previously, sec squared theta d theta. And so in the numerator, we have sec squared theta, and the denominator, we have sec to the power 6 theta. That reduces everything to 1 over sec to the power 4, 1 over sec to the power 4 theta. So the reciprocal of sec to the power 4 theta would now mean that is cosine to the power 4 theta. And I would like to split it into cos squared theta times cos squared theta. And that means that now in place of cos squared theta, we have cosine 2 theta plus 1 over 2. And so we square that. And so the denominator here becomes 4. So we have 1 over 4 as a constant outside. And so we have cosine 2 theta plus 1 squared. And so that we have now the integral of cosine squared 2 theta plus 2 cosine 2 theta plus 1. And as we continue, we have now a quarter, the integral of cosine squared 2 theta plus 2 cosine 2 theta plus 1. We would like to reduce this square into a non-squared trigonometric function. So again, we have, in place of cosine 2 theta squared, we have cosine 4 theta plus 1 over 2. And that means that now we have the integral of a quarter times 1 over 2 cosine 4 theta plus 2 cosine 2 theta plus 3 over 2. And so when we integrate these, we have now quarter times in bracket 1 over 8 sine 4 theta plus 2 over 2 sine 2 theta plus 3 over 2 theta. And then we have an integration constant C. So that means that when we multiply this a quarter across, we have 1 over 32 sine 4 theta plus 1 over 4 sine 2 theta plus 3 over 8 theta plus the integration constant. Okay, so the next thing we'd like to do is to express everything in terms of the single angle formula, because we want to take things back to the x domain. So the first thing I'll do here is sine 4 theta is the same as 2 sine 2 theta cosine 2 theta. And then sine 2 theta here is the same as 2 sine theta cosine theta. And so this 2 now makes this 1 over 16. And then in brackets, sine 2 theta becomes 2 sine theta cosine theta. Cosine 2 theta becomes cosine squared theta minus sine squared theta. And then here we have 1 over 4 sine 2 theta, 2 sine theta cosine theta. So then the next step is, since we said x is equals to tan theta, and from the basic definition of tan theta, if we have an angle here of a right angle triangle theta here, since tangent of this angle is the same as the opposite over the adjacent, so this would be x over 1. So we would take the opposite to be x and the adjacent to be 1. And therefore the hypotenuse would be 1 plus x squared, square root. Therefore, sine theta being opposite over hypotenuse would be x over the square root of 1 plus x squared. And then cosine theta would be adjacent of hypotenuse would be 1 over square root of 1 plus x squared. So we would put this expression in place of sine theta and cosine theta as respectively as shown here. So therefore the integral of 1 over in bracket x squared plus 1 close bracket cube is the same as 1 over 16 times 2. In place of sine theta we have x over square root of 1 plus x squared. In place of cosine theta we have 1 over square root of 1 plus x squared. And times in bracket, in place of cosine squared theta would have the square of 1 over square root of 1 plus x squared, minus, in place of sine squared theta, we would have the square of x over square root of 1 plus x squared. And then plus 1 over 2, because this 2 cancels with 4 here, so we have a half remaining there. A half over, in place of sine theta, we have x over square root of 1 plus x squared. And then cosine theta becomes 1 over square root of 1, 1 over square root of 1 plus x squared. And then plus, in place of 3 over 8, in place of theta is the arctangent of x. So we have arctangent of x, since we said x is the same as tan theta here. So then we continue simplifying this. So we have 2 here, making this 1 over 8, since 16 divided by 2 is 8. And then so x in the numerator times 1 becomes x. Square root of 1 plus x squared times square root of 1 plus x squared becomes 1 plus x squared. And then here we have this term squared becomes 1 over 1 plus x squared, minus this term becomes x squared over 1 plus x squared. And then here the numerator x times 1 is x. Square root of 1 plus x squared times square root of 1 plus x squared becomes 1 plus x squared. And so plus we have 3 over 8 arctangent of x plus the integration constant c. And then 1 over 8 here stays there. And then here we have x over 1 plus x squared remaining. And then now we combine this. The denominator is the same. So 1 plus x squared. Numerator, we have 1 minus x squared plus a half. This remains as it is. And then that becomes now, when we multiply x across, the denominators are the same, and then the denominators become 1 plus x squared squared. So we have x minus x cubed in the numerator, plus 1 over 2, x over 1 plus x squared, and then this remains as it was before. So here, the common denominator will become 8. 1 plus x squared squared. And so this becomes x minus x cubed bracket plus this denominator divided by this becomes 4x. Becomes 4 times 1 plus x squared. So the numerator here becomes 4x times 1 plus x squared. This remaining part remains as it is. So that remains there. And so now we can see here 4x times 1 plus x here. This becomes 5x. 4x times x squared becomes 4x cubed minus this x cubed becomes 3x cubed. So in the numerator, we have 3x cubed plus 5x over 8 times in bracket 1 plus x squared plus bracket squared plus 3 over 8 arctangent of x plus the integration constant c. And this is the final answer. I'm glad that you were able to stick around with us. Thank you so much. For those of you who have not subscribed to our channel, we do encourage you to subscribe to our channel. But again, it was an absolute pleasure sharing with you the solution to this problem. Until next time, bye-bye.